Oh, it has been a crazy morning. I apologize for us starting so late. We had a bit of technical difficulties, and I can't see my speaker notes, so who knows what I'm going to say this morning. So welcome to What Humans Can Learn from Machines. You know, most times machines learn from us, but for the next 30 minutes, we're actually going to learn from the machines. Okay. All right. So, people often tease me because I give my AI names, okay? And I even call Alexa she and her versus it. So just know that's the crazy type of person you're dealing with this morning. So this is SAM. SAM stands for Suspicious Activity Monitor. And he, yes, I said he, is a predictive policing machine learning algorithm that I created. So just think pre-crime from Minority Report. And so SAM uses computer vision to look at a situation. He pulls out attributes from the photo or from the video, and he sends it to his machine learning brain to make a prediction on whether or not a crime is about to occur. So anyone can talk to SAM today. You're walking down the street and you see someone you think is engaged in suspicious activity. You take a picture, you tweet it to SAM, all the magic happens, and he'll send a response back through Twitter that says, oh, you need to run for your life, or you're safe. So I learned so much when I created SAM, and some of that I'd like to share with you today. So quickly, before I get started, let me tell you a little bit about myself. So my name is Keisha Williams. So I'm sure in your heads you were calling me Kesha, but that's okay. That's the story of my life. I've worked a lot of fun places. I've been in IT for about 23 years now, and I definitely have the gray hairs to prove them. I hide it very well. So like I said, I've worked a lot of fun places. And so usually whenever I put up this slide, eyes always zoom in on the NSA. So yes, I started my career there, and I have a lot of fun stories that I could share about that place, but if I did, I'd have to hunt you down and kill you. So I don't answer a lot of questions about the NSA, but I can talk to you about Chick-fil-A. Chick-fil-A. So this is where I currently work, in the IT department. And yes, Chick-fil-A does have an IT department. I've been there for about 13 years now, and there are two parts to my role. There's the boring part and the fun part. So quickly, the boring part, I am a full-stack web developer. I work with Java and Spring on the back end and Angular on the front end. So that's the boring part. Now the really fun part, I get to lead innovation teams as we research cool and emerging technologies like machine learning, facial recognition, computer vision, and the list goes on and on. And one team actually won the Think Different Innovation Award for using artificial intelligence and voice-first technology. But I've really had the most fun with machine learning. So what is machine learning? In layman's terms, a machine learning program or an algorithm is one that studies past data to find trends and patterns. And then the trends and patterns found, they are actually stored in a mathematical model. And so sometimes you'll hear data scientists talking about the model. And so that's basically what the model is. It's the collection of trends and patterns found during this data analysis process. And the cool thing about this model, it can be consulted and queried for questions. So whenever you have a new data set come in, you can query the model for a prediction, like a crime prediction. So that's machine learning. So how many software developers do I have in the room? Okay. And even if you're not a software developer, you can identify with this question. How many of us have our own personal preferences? So everybody should be raising your hand at this point. So we all have things that we like and things that we don't like. So do you prefer Coke or Pepsi? That's a personal preference. Do you prefer McDonald's or Chick-fil-A? You guys know who I prefer. It's Chick-fil-A all day, every day. And oh, the milkshakes are so delicious. Oh, look at this. Oh. Do you prefer a beach or a ski vacation? So we all have personal preferences. Now, for me, I prefer a beach. If it's a vacation and there's no beach, then it's not a vacation. And so we all have our own personal preferences. And when we talk about machine learning, we call that personal preference a bias. And so now when we say the word bias, it doesn't sound as nice, does it? So we all have our own personal preference and our own biases, and sometimes we aren't even aware of those preferences. And we call that an unconscious bias. And so when we pass this bias on to the machines, it's not a good thing. So how many developers in here do I have that work with AI, artificial intelligence? So maybe you build Alexa skills, you work with computer vision, you build Twitter bots, chat bots. Okay. So when we talk about the personal preference and the bias, and we talk about applying that and using machine learning, machines learn from us, right? So either they learn through the data that we feed them, or sometimes they learn just by looking at the data that we feed them. And so when we talk about what we can teach machines, really, what can machines teach us? And so like I said, in creating SAM, I learned so many different things. So the first lesson that I'd like to share is that machines actually start out bias-free. So they don't have a preference. They don't prefer Chick-fil-A over McDonald's, but they learn that preference really from the data that we feed them. And so machines start out bias-free. Who's heard the story about Microsoft Tay? Only a few of you. Okay, I'll talk about that artificial intelligence program later, but bias played a real part in that. Okay, so there are two ways to teach bias. The first is through the data, okay? So the data that we feed machine learning programs, sometimes that data can be insufficient. And so for example, I don't know if you guys heard about the Google AI program that really accidentally classified a few African Americans as gorillas. Who heard about that? Who heard about the facial recognition program that couldn't even see African Americans? And so the data, those are two prime examples of the data set being insufficient and also lacking diversity. So that's one way that we teach bias. Another way that we teach bias is really through the design. So the design of the algorithm, it may just be poorly designed. So what the developer tells the machine is important, it could be incorrect. So those are the two things that lead to bias. And so lesson 2, this was a big aha moment for me. Machines can actually remove human bias, providing for a more fair and equitable future. And that to me is very amazing. And I'll share with you a case about Sam and one thing that I did to really make sure when he's predicting crime, he's bias-free. So that was my second lesson. Machines can actually remove human bias. So machine learning is used all over the place today. So for example, it's used in loan approvals. So maybe for a car loan or a home loan or maybe a small business loan. There could be a machine learning program that says yes or no. Machine learning is also used in employee hiring. So will this person be a good fit for this company? And then also it's used in crime. So imagine a world where bias does not exist in any of those situations. Just the thought of that is very, very exciting. So let's touch a little more on using machine learning when it comes to predictive policing. And so I don't know if you guys are aware, but there are some courthouses where judges use machine learning programs to determine if someone is going to be a repeat offender. That blew my mind. It's also used in Chicago, Pittsburgh, the UK Metropolitan Police. They use it to identify hotspot areas, so areas where they think crime is likely to occur. And so when I was creating SAM, I excluded race. So SAM looks at a lot of details like age, gender, location, time of day, but I intentionally excluded race. So as the developer, I made a conscious decision when programming this AI. I did not want him accused of racial profiling, and so I excluded race. So that was a real aha moment for me, because it shows machine learning can actually exclude and remove human bias. So that's really cool. So lesson 3, nowadays, developers have an ethical and moral obligation. So when we are actually coding these AI programs, we have to think about what we're doing from an ethics and from a moral perspective. So it's no longer okay to just say, you know, my boss told me to code this, and I'm just going to do it. Really now, as a developer working with AI and machine learning, it's our responsibility to make sure that what we build doesn't destroy someone's life. So we have to be the ones to raise our hand and say, hey, you know what? This program that I'm building, did you realize that it can't even see African Americans? So it's something that we need to do. We need to create sufficient training data. So now, developers, we really have to think about the ethics and morality of what we're doing. Okay, and yeah, we just really have to take a long, hard look in the mirror and understand what our preferences are, what our biases are, and make sure that we work hard to not transfer them to the machine. And so machine learning can really provide a more fair and equitable future, and it's very exciting how this technology can actually transform society in ways that we can't even begin to imagine. So if you remember nothing from what I shared with you today, just have that excitement about machine learning and what the technology can do. And then if you're working with machine learning, just be very deliberate about not passing your own personal biases onto the machines. And so I'm going to do something a little different today. I believe in paying it forward. And I am honored to have Emily Maxey join me on stage. She works at a software development firm in Tennessee, and she is an aspiring technical conference speaker. So welcome Emily to the stage of her first technical conference.
Thank you.
My
it's great
pleasure.
to be here.
I am so excited that I'm not up here by myself anymore. And so Emily is she works at a software development firm in Tennessee, and she's going to share with us some of her lessons learned when working with machine learning. So first, Emily, how are you today?
I'm really good. I'm excited to be here.
I'm glad that you could join us. So tell us, what do you see as the impact of machine learning on society?
I think it's one of the really exciting technologies of our time. I'm not a data scientist, but we have data scientists at our company who I've spent a lot of time with and learned a lot from, and they kind of explain it as, you know, big problems that can't be solved in traditional ways. That's where machine learning really thrives. Yeah. And I see so many big societal problems that could use solving, and it's exciting to think that this is another tool set that we could apply to those problems.
Very good. So why do you find the topic of bias in machine learning so interesting?
I find the topic of bias in general really interesting because it's something where the more I learn about it, the more complex of a topic it is. they've actually done studies, and people who think that they are unbiased are more likely to make biased hiring decisions because they think they're immune from demonstrating bias, and it's not something they have to think about. So the idea that the machines that we're building could be biased, or that the machines we're building could mitigate bias, is just incredibly fascinating. And so we're using that same idea to solve some really, the idea of developing women in tech is such a big societal problem and something that's really hard to fix. And so we're really taking a look at the macro level at our company. Right now, we don't have any female engineers, and we're all, me and all the guys are really passionate about fixing that.
Yeah.
And so, I'm working with our data science team to, we're actually going to use Google's word-to-vec algorithm and natural language processing algorithm to analyze all of our Slack communications and look for both gender and racial bias in it, and use it not to identify people and say you're doing this wrong, but to use it in aggregate as a learning mechanism so that we can say, oh, okay, this may be why we're not attracting the people we're trying to attract. There's also tools that you can use to analyze your job postings for gendered language, which I think is amazing and cool. So there's a lot of really exciting things, and I think especially as technologists and people in the tech field, it's such an incredible tool that we have to kind of make tomorrow a different tomorrow.
Right. And what I've seen when working with machine learning algorithms, they definitely amplify bias. And remember, I mentioned about Microsoft Tay. So Microsoft Tay was this Twitter bot that Microsoft released, and it was supposed to learn by interacting with users on Twitter. And within 16 hours, Tay learned to be a Hitler-loving racist. And so it just shows that machine learning really amplifies the bias that's already there. So it's very important when we build systems to make sure they're bias-free. And our last question for Emily, what's the most important lesson you've learned about bias in machine learning?
I think machine learning is one of those fields. I mean, all fields are fields that could really benefit from diverse teams working on them, but I think machine learning is even more so because the end users of these products are not digging into the data and analyzing whether or not it's trustworthy. They say, this is technology and it tells me X, Y, Z, I'm going to believe it. And so there are some real opportunities for diverse teams to make a real difference and point out problems like hey, this Twitter bot might become a Nazi. That's the problem.
Yeah.
And I think, like you mentioned about excluding race from SAM, that's something that, a white programmer might not have thought of. And so having diverse teams, I think, even more so for machine learning, is incredibly important.
Yes. And that's it. Thank you guys for your time this morning. I don't know if we have time for questions or not, but thank you.